Then today we are still working with tangent lines, but we are also working with what are called secant lines. And today they are tying into how we can use secants and tangents to find missing angle measures in a circle. This is where, again, we had, I think, 2 theorems we looked at yesterday of properties to keep straight with tangent lines specifically, and now you will have, there are 3 theorems we're going through of what to keep straight for how to use secant and tangent lines to find angle measures. We are still working on with secants and tangents tomorrow, but how the lengths of the parts of secants and tangents, how those can be related to find missing segment measures. So starting out, we have what a secant line is. So a secant is a line that intersects a circle in exactly 2 points. Remember from yesterday, a tangent was a line that intersects a circle at exactly 1 point. It just touches a circle. A secant, another way to think of a secant, it's a line that just goes through the circle. So it's going to intersect it twice. It goes through it. So if you look at this diagram for circle C, line J and line K, those are both secants of circle C. You could think of it this way too. Secant lines create chords. So if you actually had where this actually intersects the circle, those points, that segment would then be a chord. So for intersections inside of a circle, so when 2 secant lines intersect in a circle, picture would look like this. And notice that intersection, it's not necessarily at the center. So it says when 2 secants intersect inside a circle, the angles formed are related to the arcs they intercept. So in words, that means if 2 secants or chords intersect in the interior of a circle, the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So what that means, there's two formulas for these 2 different angles because you do have 2 pairs of vertical angles. So angle 1, these 2 angles are both congruent, and then these 2 angles are both congruent. So if you're finding the measure of angle 1 or even this angle here, you would take 1/2 multiplied by their intercepted arcs, so arc AB plus arc CD. So you would add these 2 arcs together and then divide that in half. And that would give you the measure of both of these angles. And then similar for angle 2 or for both of these vertical angles here, the intercepted arcs are BC and AD, so you would add those 2 arcs together and divide that in half. So when they intersect in a circle and they're not at the center, that's how you can find the measures of those angles. So if we look at some examples of how to apply this, 1A here, we are looking for X in all of these circles. So X is this angle. So for that angle and its vertical angle, the intercepted arcs are already labeled. So to find X, I'm taking half of the quantity and I'm adding these 2 arc measures together. So half of 116 plus 47. Okay, and then I find the easiest way to type this in your calculator, just make sure you're typing it incorrectly, is add the 116 and the 47 first, and that gives you 163. And then multiplying by a half is the same as dividing by 2, so then just divide that in half, and you get 81.5 would be the measure of X. All right, 1B, this is similar in the sense that we're finding an angle, but we are not given the intercepted arcs. We are given the opposite arcs. There's a couple ways to go about this. I'm going to explain one way. So say I wanted to find the intercepted arcs. Well, actually, instead what I'm going to do, I would find one of these angles first since you have these arc measures. So let's say I just call this y. I'm just going to call it something different. So I'm going to find y first because I have those arcs. So I have y is equal to half of those two arcs added together, so 55 plus 75. So if I add 55 and 75, I get 130. Divide that in half, and y then is 65. And then to find x, if I know y is 65, how do I find x? Yep, first, yeah, subtract it from 180. So x then is 180 minus 65, which is 115. Okay, questions on that one? So you might have to find other things in the problem before you can find what exactly you're looking for. Then C is a little different yet. You're actually given an angle and you're trying to find one of the two arcs that's missing. So you still want to set this up in your equation the same way, except you're not going to have x equals, x is going to be somewhere within your equation. So I know that this angle, the 128, must equal half of the two arcs added together, so half of x plus 154. So here x is just kind of in the middle of my equation, and now I have to solve for it. So to me, the easiest way to solve for x is to first get rid of the 1/2. How can I get rid of the 1/2? Yeah, multiply by the reciprocal, multiply by 2 on both sides. That 2 and 1/2 cancel, so I have 128 times 2 is 256, and then I just have the x plus 154, which then I can subtract the 154 to get x. So x in this case would be 102. Okay, so different variations, but using kind of that same formula. An angle created by two secants or two chords that intersect in a circle is half of the two intercepted arcs added together. Okay, questions on any of those three? Okay, then the next theorem, and actually if you have a highlighter or if you hadn't circled it, this is something just to kind of draw your attention if you're looking back at your notes. Any of these theorems that have these formulas in them for how to find missing angle measures or missing lengths of segments, I would maybe highlight or circle just so if you're flipping back through notes, it kind of draws your attention to it. So for the next theorem, this is similar to the inscribed angles we had when your vertex is on the circle. So it says if a secant and a tangent intersect at the point of tangency, which would be on the circle. So you can see here line A would be a tangent line, and then the AB, that ray, would be a secant because it goes through the circle. The measure of each angle formed, meaning angles 1 and 2 here, is 1/2 the measure of the intercepted arc, and we saw that with inscribed angles also. So this angle 1 is half of the arc AB, so you'd find this arc divided by 2 to get your angle 1, and then 2 is half of this arc ACB. So that's what it's saying here. So it's not quite an inscribed angle, but it is formed by a secant and a tangent intersecting on the circle at the point of tangency. So for the second set of examples here in 2A, we are given that angle measure, and we're trying to find the measure of arc JLK. So just make sure that you know which arc you're trying to find. I am trying to find that intercepted arc. So if the angle is 116, how would I find the arc? Multiply it by 2. So 116 multiplied by 2. The angle is half of the arc, so the arc is 232 degrees. Or if you just have 232, that's okay. And then 2B says find the measure of angle RQS. So I'm looking for this angle here. If the measure of arc QTS, so this arc is 238. So how would I go about finding angle RQS? Ethan? Yeah, so the entire angle is 360, meaning this arc QS, the minor arc, is 122. Just subtract 238. Well, here, I'll write this down in case you want to write it in your notes. 360 minus 238 is 122. And then if I divide that in half, 122 divided by 2 gives me the angle, and that is 61 degrees. Okay, so again, you might have to find other information first. So it does tie in other things we've talked about from this chapter or others. Questions so far? We have one other theorem to look at that deals with intersections outside of a circle. So secants and tangents can meet outside of a circle. Notice in all three of these diagrams, that vertex A is outside of the circle. And it says the measure of the angle formed involves half the measures of the arcs they intercept. So it says if two secants, meaning in this picture these are both secants, a secant and a tangent, so the next picture has a secant line and one tangent line, or two tangents, so the third diagram is two tangents. But all of these, even though the formula might be labeled differently because of the intersections or with different letters, it's the same formula for all of them. The measure of the angle formed is half the difference of the measures of the intercepted arcs. So if I look at this one, it's saying the measure of this angle A is half of the larger arc minus the smaller one. But the two intercepted arcs, it's the larger one minus the smaller one, and then dividing that in half. And that formula is the same throughout these. It's just, again, labeled differently because of where the intersections occur. But again, that's when you have a vertex outside of the circle formed by two secants or two tangents or one of each. So if I look at the examples below, I'm just gonna highlight these. So one thing you have to keep straight today, because this formula is very similar to the first one we used where we were adding two arcs together and dividing it in half. That's what you have to remember is when do I add the two arcs and divide it by 2, or when do I subtract them and divide by 2. So it's whether the intersection is inside of the circle is when you add them, outside is when you subtract. So for number 1 here, we're trying to find the measure of angle L. And all we know is that this arc here, HK, is 102. So similar to the last example, I need that larger arc, and I can find that by subtracting this from 360. So 360 minus 102 means this arc is 258. So then the measure of angle L, applying the formulas that are above, is going to be half of the larger arc, 258, minus the smaller arc, 102. So again, subtract them first and then divide it in half. If you subtract them, you get 156 divided by 2. gives you the angle measure of 78. All right, and then I'll go through example 2 with you also. This one we are looking not for the angle, but for the arc CD. So just for equation purposes, I'm going to label that x right now. It's what I'm trying to find. I'm just going to assign a variable to it. I'm trying to find CD. So I have the angle is 56 and then BC is 95. So again, still using that formula. I'm starting out with the angle measure. So the angle of 56 is equal to half of the larger arc, which is my x, minus the smaller arc, which is 95. So x is within the equation and I have to solve for it. So similar to how we did this in one of the examples on the front, if I get rid of the 1/2, I can multiply by 2 to do that on both sides. And 56 times 2 is 112. And that equals, I just now have x minus 95. And now all I have to do is add 95 to both sides. And so my x, which was the arc I was looking for, is 207. Okay, questions on those two? Otherwise, there's many different ways you're going to see on your assignment, either even different pieces of information given. It's all about using the formulas we've looked at today, manipulating them to find whatever it is you're looking for. So if you haven't already, go ahead and answer 3 and 4. I'll come around and I'll pass out your practice. And then you have time to work on that and let me know if you have questions. And actually, we have enough time. I think I'm going to pass back your quizzes also. I forgot to do that yesterday. So I'll get your quizzes back to you. We do have enough time. They're quizzes, so you can keep them.